Don't you just hate it when you buy something new and it doesn't last? And in this case, I bought myself a brand new cordless lawnmower back in the spring with a 48-volt battery and a charger. I've charged the battery twice, only twice. Went to charge it the third time, the freaking charger is dead. Now, it's got a 5-year warranty, so I can take it back no problem, but I want to see what went wrong. Let's check it out. Earlier this summer, I bought this fancy new Yardworks cordless lawnmower. I loved it. It's great. 5-year warranty on it. Good thing. I've charged the battery twice because normally I can cut the lawn usually 3 times on a single charge. This thing will run the lawnmower for about an hour before it needs to be recharged, and I can typically do the lawn front and back in about 20 minutes. So I've gotten like 3 cuts per charge. As you can see, my battery is drained. It's down to 1 bar, and we've still got our full voltage, 41 volts on here. I put it on the charger though, and the charger is not charging. Nothing lighting up. If I test the charger, I will see that there's no voltage. So something in this charger has gone foobar. Now, it's got a 5-year warranty, so I'll be taking it back to the store for sure. But before I take it back to the store, I just figured that we would take this thing apart and see if we can spot any reasons why it's not charging. Now, it has not been plugged in other than when it was charging the battery. So when I've charged the battery, I've charged it twice. I charged it when I first got the lawnmower, and then after I used it for like 3 cuttings, and I was down to like 2 bars. I was down to this one. Right now I'm down to 1 bar. I was down to that bar. I charged it up, and then it's been used like 3 times. To cut the grass, this time I'm down to 1 bar, go to charge it, nothing happens. This was not plugged in. When it was not being used, it was unplugged, sitting on a shelf. Plugged it in to use it, doesn't work. So let's see why it broke. See whether it's something simple. I think I'll still take it back to the store. I should take the whole freaking lawnmower back, put the whole thing back in the box, take everything back and say, this broke. I want to exercise my 5-year exchange warranty. Give me a new one, but I'll probably just take that back. Anyway, let's pop it apart and see what the hell went wrong with it. They really don't want you getting into this. I'll show you why. Check out the screws they put into this thing. They're a Torx type screw, and I don't have a Torx bit that's long enough, but I do have a flat blade that I filed the edges down a bit on, so it will work. But I don't have anything against Torx, except for I just don't have any Torx bits that are long enough to reach in here. With the handle on it, it's the handle won't fit through here. The protrusion is just a little bit too small. So you need a Torx bit that, like this part, won't fit because it's the same size. If I had a Torx bit that was, would fit in there, then great. But you see, it's exactly the same shank size. I don't have a Torx bit that's long enough. My Torx bit is only like that long. It won't reach it. But that's why this little filed screwdriver comes in handy. I'm able to crack into a lot of things this way. We'll see why this power supply is not working, and is it something minor. Was there a power surge? Who knows? It was plugged into the same circuit that my, it's not the same circuit that my bench is on. It was plugged into the same circuit that my lights for the workshop, and there's an air compressor that's plugged on there, although I don't think the compressor came on while this was plugged in, because it typically only comes on when I'm pumping up tires. Anyway, there is the unit itself. And I'm just looking to see if there's any fuses, because that would be the first place to look, is for a blown fuse, right? I don't see any fuses on here. Okay, next we'll pop out the board if it comes out. It's held in place by, looks like one screw. Well, I guess first things first, I'll check and see whether the capacitor is charging up. So we'll plug in the power and see whether the capacitor is charging up. This will be the AC side. Well, this is the rectifier here, so this will be a high voltage here if this capacitor is charging up, and indeed it is. It has 166 volts. So there is power getting to the unit itself, but there's nothing on the DC side. As you can see, it's at 0. So I wonder where the fault on this is. Could be the oscillator's not working. Now this is still going to be charged, so I gotta discharge this capacitor. Otherwise, could get bit very easily, because this is holding a charge because the oscillator is not running. As you can see, it's holding 155 volts. Not for long. That would have bit. It's down at 5 volts now. We'll just neutralize that again. Let's pull the board and see if there's something obvious, like a bad connection somewhere in the primary side, because the oscillator does not appear to be running. Anything obvious? I'm looking around the transformer and the transistor here, the MOSFET. Obviously, this is the optocoupler. Whether we can spot anything that looks bad. There's a conformal coating. You see it on this board, because this obviously is designed to be sitting out in a shed or something, right, where it could be damp. So they've got a coating on the board itself. That's what you see here. Looks like there's something between the pins here over this break in the board, but that's actually the conformal coating. So you can get that connection there. Try reflowing that. Heat up the soldering iron. We'll reflow a couple of these connections. See whether that will bring this unit back to life. Otherwise, it's going back, because, as I say, this is not even. I think I bought it in June. Right now we're at the end of August, so May or June I bought this. It's not. It was used twice. 2 charge cycles is all I got on this thing before it decided to pack it in. But it doesn't look to be anything really obvious. How does this IC look? Get the magnifiers on and get a better look. This could be a fusible resistor right here. I wonder, is it open? We're fine. 1.2 ohms, so that's not that was not bad. That's a fusible resistor right there, but it's 1.2 ohms. What is it showing here? I'm measuring the leads itself. If I put my meter probes together itself, it's going to measure the actual resistance of the leads, which is 1.1 ohms. So that resistor is fine. I'm just going to reflow the transistor here, and do the same for the transformer, and we'll see if anything happens when I power it up again. I'm probably just going to end up taking this one back because it's under warranty. I don't want to do too much to it because it's under warranty. Did I mention that it's under warranty? I take a shot every time I say warranty. I'll leave my tip a bit here because it's a bit oxidated. Now, do remember, I can't see what I'm shooting. I'm looking through the magnifiers at what I'm working on. I can't see that my head's in the shot because when I look up, of course, my head's not in the same position. So, sorry about that if you can't see exactly what I'm doing, but I'm kind of concentrating on what I'm doing. I'm resoldering the board. I'm going to leave the camera run here just so you can see what I'm finding as I go through this to see whether I can actually get this unit to work or not. So I'm basically going to resolder the IC and every connection. I'm going to do all the chip resistors, a couple of capacitors on there, there's a transistor, but I'm going to basically do every connection on the primary side, including the transformer, the MOSFET, the IC. I think that's a little start cap right there. That connection looked a bit... is that a startup cap? Yeah, that's a little start cap there. That connection looked a bit little suspect. We'll do this other one over here too. There was a few connections. A couple of the chip resistors, as soon as I touched one side, the other side lifted, like it wasn't tacked down properly. I'm starting to get a little more confidence now that this is going to work, because I have found a few connections. A little 0 ohm jumper, like that one. And I'll make comments that there's a few that really look kind of flaky as soon as I touched them with the soldering iron and they started to move. I noticed something in this particular part of the circuit because had the oscillator been running, which it wasn't, because had the oscillator been running, that cap would have discharged when I unplugged power. But it didn't. It held 160 volts, which says the oscillator's not running. So that's why I'm concentrating in this area here where these resistors are that bias it on and so forth. So if it was just a simple cracked connection or something not soldered down right, that could certainly cause this to not work. And obviously if I solder this and it works, I won't be returning it to the store, I'll be using it. But if this doesn't work, then back it goes. That resistor didn't look like it was soldered down either, because as soon as I touched one side, it actually lifted. Or lifted pretty easy. Alright, I think I can try this out now. See whether it produces any voltage. I don't think I've shorted anything out here. Be careful. Obviously, if someone opens it up, they'll know that it's been worked on, but I'm banking on them not opening it up. Okay, I got power. Let's see if there's any output on the terminals down here now. Oh, I got 4 volts. Okay, well, I got 4 volts coming out of it now, so that's more than I had before. What happens if I put the battery in? Will it turn on? It's flashing. It's working! Son of a gun! Okay. I fixed it. Let's throw it back together. Let's throw this sucker back together. And you'll see that now that it's running, so obviously it was a connection problem on that up in here. But what you'll see now, if I power it up and then unpower it, we'll see that capacitor will discharge pretty quick because the oscillator is going to run. And the oscillator wasn't running before. So let's just power it up again. So I've got my 160 volts on here now. 165 volts. When I unplug the power, we'll see that this 165 volts is going to drop, you see, because the oscillator is running, and it wasn't running before. So it'll drain down pretty quick. Just to prove to you guys that I actually did fix it, because we measured this before and it was holding voltage, and I got a big spark when I went and did this, which I won't get now because it's discharged. Anyway, so there we go. I fixed it. Right from the factory, obviously there was a connection that wasn't done properly. It sure looks that way to me, but now it's fixed. I can put it back together and charge up my battery. Alright, here we go. It's fixed. It's all back together. Whoops, might help if I put the battery on the right way. There you go. Now it's charging. I'm happy. I can now mow my lawn again. Once the monsoons set in and it starts raining and the grass actually starts growing, because I'm one of these people that don't tend to water my lawn a lot in the summer. I try to conserve water and I let it kind of turn brown a little bit. Actually, big time. But it'll be raining soon enough, therefore the grass will be green and I'll be out cutting it every week again. Thanks for watching. We'll catch you in the next one. Bye.